So let me introduce our speaker today. So our speaker is Samuel Drapeau, who is associate professor at Shanghai Jiao University in China. So it's extremely late right now for Samuel. So his position is shared between the School of Mathematical Sciences and the Shanghai Advanced Institute of Finance. And Samuel has been in Shanghai for the last 5 or so years. Before that, he received his PhD in 2010 at Humboldt University in Berlin, and he held positions at Humboldt and at Technical University in Berlin, and then he moved to Shanghai. Samuel works on stochastic convex analysis, decision theory, risk uncertainty, data analysis, BSDs, and today he will talk about on detecting spoofing strategies in high-frequency trading. And I think the floor is yours, Samuel. Welcome.
Okay, thank you very much. So hello everyone, so good evening, good afternoon, good morning, depends where you are right now. So it's many thanks for the invitation. So this is almost the first time that I'm holding a talk online in that kind of situation. So I'm going to speak about detecting spoofing strategies in high-frequency trading, and this is a joint work with my PhD student, Tong, who is in Shanghai, here at Shanghai Jiao University, as well as my former master student, Ning Lan, and Andrew Day, who now graduated from Western University in Canada. So the origin of this project came from joint work or a joint project between China and Fields Institute, which is so-called Fields China International Problem Solving Workshop for Finance that has been quite successful and organized over several years. And 2 years ago, I started I was there with the students, with Ning Lan, Andrew Day, and we came into contact with TMX, which is a Toronto Stock Exchange in Toronto. And we had a first-hand overview of the huge amount of data that they have, in particular level 2 data and high-frequency trading data. And starting from there, we were quite interested into trying to understand, or we were quite fascinated about how this high-frequency trading, or the limit order book in itself, might allow for some kind of spoofing behavior or manipulative price behavior. So we were really fairly new in this context, and so we started to look around and try to work. It took a little bit of time, a little bit more than I was expected from the beginning. First of all, because you have to get used to work with a lot of data. So there is a big difference between just writing equation on a piece of paper and just taking your computer and try to load huge amount of data and try to understand what is coming out of this noise. And the second thing is that since almost 1 year, we are quite far apart. And when you work on project where you have a lot of data, like then collaboration starts to be very, very difficult because you cannot send data back and forth and try to see how it is working. But TMX was quite helpful in this regard by providing not only data and market insight, but also a platform where we could really work on data on distributed cluster so that it was possible to do. So why spoofing? So let me discuss a little bit about it. This is, oops, yes. So this is something which is actually an illegal trading behavior on the market. So legally, it means that you're trying to manipulate the offer and demand on the market. So posting some kind of market orders, limit orders, in order to drive the market into the wrong direction by suggesting that there is a lot of supply or a lot of demand. And you post this order without intent to purchase them in order to drive everyone away from the equilibrium price and then take advantage afterwards. And recently it has been notice that in high frequency trading, there is more possibilities that this kind of behavior can happen. And this is pursued and can be defined quite largely. So as you can see, there are 3 examples here. The last one being like 2 days ago, where JP Morgan has been settled a lawsuit for $1 billion, right? Where 15 traders were spoofing the commodity market as well as the treasury bond market over several years, incurring a lot of losses for the counterparties, right? They drove the market into the wrong direction. So, however, since the law definition is a very loose definition, it's kind of very difficult to try to detect this kind of spoofing. So the main way people are detecting or try to prosecute this kind of behavior is through just like the traditional detective work, where you have some people that are bragging about spoofing the market, which is the case of JP Morgan, or just tapping phones, or just adding some clues from insider, but not really from the market data. So you cannot really see them. And indeed, this is quite difficult to detect spoofing because, first of all, you're in an environment of high frequency. So this is a typically high frequency trading behavior. And when you have high frequency trading, you have a lot of data, a lot of people that are trading all around the clock. So it's very difficult to filter some kind of illegal behavior, which is already not clearly defined, right? So you have high frequency trading, multiple venues. Yeah. You also have the fact that the limit order book, this is a so-called this is a very, very complex object where over time you have matching of orders. So there is no accurate way to model the limit order book, right? There are many, many ways to do that, but nothing is really totally clearly understood. And there is no easy way also to trace orders. I mean, you're in a stock exchange, so when you send orders, like limit orders or market orders, they're totally, they're kind of anonymous. They're going to be matched. Yeah? So this is a double auctioning system. So they're going to be matched, and you don't know who is your counterparty. It's not really an over-the-counter procedure. And it is also not clear what is the impact of spoofing. So if you want to detect something, you want to know actually what is the impact of this behavior on the market, right? So it seems to be quite difficult to do that from the very beginning, and we were at the beginning not clear about how to go. But if you look on the other hand, a potential spoofer is facing exactly the same of problems when he's trying to spoof, right? He's also in this high frequency environment, right? So it means that if he wants to spoof, he cannot do that by hand. Yeah? You have really to program an algorithm that's gonna implement this spoofing strategy in order to drive all the other algo trading traders. And so if you have an algorithmic strategy, it must be relatively simple, for the main reason that you have to act at an extremely high space, and the latency, I mean, if you're too slow, yeah, so computing as a processing data, analyzing data, trying to find the right signal, how to spoof, and then posting the order should be done in an extremely fast manner. So it means that this computational burden requires from your algorithm to be relatively simple. Okay, so this is something that we are looking at. And the second thing is that the limit order book is a high dimensional object, right? That is updating very fast. So this algorithm, in order to process this kind of stuff in a relatively fast way, it must respond to basic stylized fact from the limit order book, not too complex. Okay, so with these premises, we started to think about, okay, well, if I were a spoofer, how I would do that. So the goal of this work is to try to understand the mechanism of spoofing. So when is spoofing likely to happen given the condition of the market? So the condition as if you're very liquid, not very liquid, how the market reacts, offer and demand, and so on and so forth. Secondly, try to find what is the market impact of spoofing, okay, because we want to quantify it afterwards. And then try to find out if it is possible to develop some kind of detection procedure. I mean, we do not claim that we have the way to do it. It's just like an intent to provide some kind of possible answers. And, but there are many others that can be done in this way. So in order to do so, we reduce the complexity quite a lot in the sense that we'll consider first a static case, means that we look at a one period model. I mean, this is now and the nanosecond after, or the second after, so to say, and try to see how I would spoof in that kind of situation when I face a limit or a book. Yeah? And the second thing is that we assume that we have a single spoofer that is facing just like Morris traders around them. There is no informed traders behind it or no other potential spoofer against it that would imply some kind of game stuff. Here it's just like me playing against the nature, right? I mean, me spoofer. Now, concerning the status fact of the limit order book, we want to model the spoofing. And from the definition, it is trying to artificially modifies the law of offer and demand in order to drive the market in a wrong direction, right? So to do that, we will use the concept of imbalance, which is a well-known concept so far, but we extend it a little bit for reasons that I will explain later. And the last thing that we did, and which is actually probably one of the most difficult, is even if it is simple, the model should be able to match the data somehow. Okay, so calibration and monitoring afterwards. And it turns out that even if you come with, you think, a very good idea, when you try to implement it, then you see that this is totally bullshit. So you have to think again about how the market is working, what is going on, and so on. So we developed in the course of 2-3 years, so we rewrote the paper several times until we got a rough idea how it is working. And this is what I'm going to present right now. So for those who are not used to limit order book, let me present rapidly about the different kind of order that are going there. So it's a double auctioning system. So order are coming in and out. And you have 3 different kind of orders. So orders that are liquidity orders, so to say. So these are limit orders where you post on the bid or on the ask price a certain volume that you propose for a certain price, okay? So in this example that you have on the screen, at the price level 19.28, you post like 100 shares, okay? And the limit order book will move from the top to the bottom, right? So in the course of a nanosecond, I mean, the algorithm from then you have a so-called market order. So market order is somehow different in terms that it takes liquidity from the limit order book in the sense that instead of posting a volume at a given price, you say, I want to have this volume for the best price. So in that case, you see here a market order of about 600 shares, right? It will hit the limit order book and you will execute it at the best available price. The best available price is 19.26, for which you have 200 shares available from previous limit orders. And so you execute them for 19.26, 200 shares. And then afterwards, you have to walk the limit order book. So meaning that you are paying liquidity costs. And so you get to 19.27 and you execute the 400 shares where, I mean, your order is finished. And then you paid the price plus the liquidity cost, okay? There is a third kind of order. I mean, there are many other orders, but these are the 3 most basic orders. is so-called cancellation. Cancellation is for limit orders that have been previously posted, right? If they are not yet executed, you have the possibility to cancel them and to eventually repost them afterwards, right? So in that case, at the level, price level 19.27, you had 600 shares, but I had a limit order there of about 400 shares, and I decided to cancel it. And so the limit order moved from the top to the bottom, and now the volume available at price level 19.27 will go down, okay, by 400 shares. So these are the three kind of limit orders, of orders that you can see in the limit order book. Limit orders, market orders, and cancelling of previous market or limit orders. So when you look at the structure of the limit order book, I mean, when I was saying that, I was coming more like from economic decision theoretical side. I was always fascinated between the offer and demand on both sides and how they interact with each other, because this gives you a signal about how the market is, right? So this is why we started to do spoofing strategy based on this notion of difference between offer and demand on the market, okay? So when we speak about a spoofing strategy, let's give a simple example where we have a market taker, so someone that wants to buy 2 shares in this very simple limit order book where you have 1 share at each level on the bid ask, which is normally it should be orange, okay? Afterwards it's going to be orange, but I mean, on the bid side between 4 and 8, and then on the ask side between 10 and 14, yes? So if you want to buy 2 shares, you will pay, I mean, you will hit first the limit order book by a price of 10 for 1 share, and then you have to go to the next tick level, which is going to be 11. So altogether, you're going to pay 21, okay, for these market orders of 2 shares. You have a second possible strategy where you say, okay, well, maybe I could wait a little bit and the market will move in my favor, right? So you can delay this market order by 1 period of time, delta, okay? So the limit order book at time 0 is like that, and then afterwards it can move by 1 tick downwards, right? Totally, as well. I mean, it's very simple movement. Move 1 tick downwards with a probability 1 minus bar P, or it moves 1 tick upwards with a probability bar P, okay? So when you execute this market order after this amount of time, then you will pay a total cost C tilde. It's going to be 1 minus P bar 19 plus P bar 23, okay? So you have to take the cost when it is going down, which is favorable for you, and the cost when it is going up. So when you compare the two, naturally, yes, when the probability of going up is lower than 1/2, it is better to wait, okay? Good. So now, when you look at this offer and demand at time 0, on both sides, this is equal. So the market is somehow even, right? So a spoofer will try to change his view of the market by modifying the supply and demand. So how does he do that? The first thing that he's going to do is going to post, instead of buying 2 shares, he will just first post a limit order, and the limit order is not a commitment to, I mean, it's not a buy order, it's not a market order, it's just waiting on the top of a limit order book. And so it's posting a limit order of 1 share at price level 11. Now, when you look at the law of offer and demand, so the offer is just like larger. So the price apparently should go down in that kind of cases. So in the good situation, the price is going to go down with the probability now 1 minus P, with P smaller than P bar. So when the price moves down, right, you cancel the order that you already posted, right, and you buy your 2 shares, and then you pay 9 plus 10, okay? Eventually, the market goes up, with limit orders, but you cancel it before it goes up because it's moving that way. And then you will buy 11 plus 12. And this is a situation where you have 1 minus P19 plus P23. So it is better. However, this is in the optimal case. What could happen in between is, since you have a lot of orders happening in this interval, you may be executed against an incoming market order, okay? So this is the moment where shit happens. Yeah? In between, you have, so your limit order that you post at level 11 is executed by an incoming market order, yes? So in that case, you cannot do anything else than sell it. So you sell the market order for a price of 11, okay, you get money. However, your goal now is no longer to buy 2 shares, but to buy 3 shares, yeah? And your probability 1 minus P is going to go down, so you have to buy 9 plus 10 plus 11 now. So you have to buy 3 shares. Or the market goes up, and this is even worse, then you have to buy 11 plus 12 plus 13, okay? So you get now a total cost, which is 1 minus P19 plus P25, which is quite large, okay? So now when you aggregate these two conditions, the probabilities that you are not hit by a market order or the probabilities that you get hit by a market order, you get a total cost, which is given by this as follows. So the execution cost, yes, so you drove already the you change or you modify the probability of moving in one direction from P bar to P, yes, so you get this execution cost over there. Then you get the gains from being executed, weighted by the probability that a market order is coming in, plus the cost of buying back this market order. Because I mean, your objective is really to buy 2 market orders. So I mean, if you increase your inventory by 1, then you have to buy 3, okay? So in a nutshell, you can really see the 3 kind of possible strategy as follows: an immediate market order with cost 21, a delayed market order, which is 1 minus bar P19 plus P bar 23, or spoofing, where you have 1 minus P19 plus P23 plus Q, okay? So the first that you can see is that first, delaying the market order is always better if the initial state of the market P bar is smaller than 1/2, okay, that makes sense. But in the case of the spoofing behavior, you see that it depends really very much on the interplay between how bearish the market will react to the fact that you modify the offer on this on the BR side, right? So if the fact of posting 1 share will push P very low, it's very good for you, right? And it also depends on how far you put this order. Here I put it at price level 11. What is the difference if I post it at price level 13, for instance, okay? And it also depends on the probability Q of getting executed up to the level where you post your market order. So if you post it very far, right, the probability of being executed will be very low. However, the impact on the imbalance will be also lower, okay? So this is this interplay that we want to study right now. Just to give a short overview of what is going on spoofing, there are many studies about the impact of supply and demand, subsequent market movements and price manipulation, limit order book. So there are really a huge amount of literature about it, which goes extremely deep. Yeah. But the quantitative literature on spoofing manipulation is rather scant, right? There are not much thing that has been done in that direction. So just to mention a couple of them, so you have Li et al. That studied in 2013 the Korean exchange market. Sorry, there is a typo here. So they changed the disclosure how the Korean exchange was posting the information. At the beginning, they were just posting 5 ticks within the limit order book that was available to the market to see what is going on. And they changed it to 10 in the depths of the limit order book. So it happens that, I mean, they showed that the spoofing behavior happens in different kind of different markets. So they made a study about it, but also they showed that, or they suggested that this spoofing behavior happens a little bit deeper in the limit order book, where people cannot really see. Okay, and so you have subsequently a lot of empirical study based on machine learning trying to discover spoofing behavior, mainly based on different notion of imbalance. But the closest work which is related to this one and that has been published recently is from Alvaro, Sebastian, and one which is a dynamic approach where the trader explicitly spoof on the top of the limit order book for gains over time. And so they studied what is the gain over time, what are the trading trajectory, and they really showed that a spoofer can make significant gains by manipulating the market on the top of the limit order book. Okay, so, but what we are trying to do right now is more like a static way and try to measure the impact of this and try to, a posteriori, try to detect this spoofing behavior. So let me come to the real setting. So the idea is more or less set up there.
Samuel, if you can interrupt for a second.
Yes.
I think this looks like a good point to have a little stop. We have a couple of questions from participants, both about what's actually legal and illegal with spoofing. So there's one question from Ibrahim. If you want to ask.
The question, where can I see the question?
Ibrahim, do you want to ask a question?
Ah, yes, I see the chat. Okay.
Yes, I can ask it one second. Let me open it. So, I mean, are there any convictions for spoofing without the traders bragging about it? And what are the reasons for this?
So far, I mean, the case of JP Morgan so far was the people that were on the market noticed that there were very likely some spoofing behavior, and then they accused JP Morgan, since it was one of the largest market participants over there, to spoof. But the way they were prosecuted and convicted was mainly through chat channels or informations through messages between the different traders, and also testimony of a former trader that was just like saying that they were really spoofing. So this is mainly what is going on, and so far I did not see a single prosecution of I mean, I don't know, but from what I saw, I did not see a single prosecution of spoofing behavior, which is based on just like looking on the market.
Thank you. Thank you.
There was also a question from Agostino. Agostino, you want to ask it yourself?
I think it was partly answered. I was thinking related to the difference between front running and spoofing, but I think you mean more that, yeah, the spoofing in the sense that you post the opposite. If you want to buy, you basically pay the order by posting sell quotes on the other side of the book.
Yes.
And I was thinking, how would you, how easy it is to determine what is your intent?
Yes.
In the sense that I might be wanting to buy and then I end up showing that I'm selling, or vice versa.
I mean, to be fair, when you look at the definition, I mean, the law definition in the Dodd-Frank Act, it's a very, very, I mean, this is a process of posting orders, limit orders, without intent to buy. But I mean, there are so many people that are, I mean, there are many other reasons why you post. I mean, what does it mean, no intent to buy? I mean, I can post limit orders. This is a principle of a market maker. I mean, you post limit orders and you cancel them as soon as the market moves, because, I mean, and this is totally legitimate, right? So it's kind of very, very difficult to prosecute it. So here, what we are presenting is more like, okay, it is explicitly a way of, you post a limit orders in order to modify the imbalance between offer and demand to drive the market down, you cancel it in order to buy a market order at a cheaper price. This is what we are doing. Okay?
Yeah, perfect. Thank you.
Okay, I think we can continue. Just one last comment. When you're leaning back away from the microphone, the sound gets quite weak, so just be aware of that. Yes, this is good, but if you sometimes when you lean back, yes.
I have a very big microphone, but no, but I know the connection is not so good. I don't think this is the microphone, but I think now you can hear me correctly.
Yes. Now it's good.
Okay, good. So let me put it very close. So let me come back to the mathematical framework, since we're going to work with that. So we model here. I mean, I try to, since it can be very messy with notation, I will use blue color for everything which is happening on the R side, and orange color for everything which is happening in the bid side. So I have a vector V, or sequence V, V0, V1, which represent the volume at different tick level on the R side of the limit order book, right? If you send a market order of size H, yeah, you can write down the cost. So you will pay P times H, which is the amount of shares that you want to buy, plus the liquidity cost, because you have to walk through the limit order book. Okay, so this is, I mean, when you write down exactly on the right side, is going to be this equation here, but I denote it by capital G of H, which is the liquidity cost of buying this market order, given the amount of volume that I have available on the R side. Okay. Now I will denote by dpx. So this is the probability of a price deviation of x ticks, yeah, in one direction or the other, triggered by posting or canceling limit orders. So as you can see, the limit order can move by posting limit orders and canceling them, but it can also move through incoming market orders that will go through the limit order book in one direction or the other also. So I will separate both together, and I will assume that the probability of a price deviation by incoming market order is kind of is not influenced by the imbalance. I mean, you can remove this assumption afterwards, but I assume that the law of offer and demand for limit order book and canceling limit order book is only influence dpx. I mean, the probability of price deviation by just limit order books, by limit orders. To be fair, limit orders represent like the huge chunk of orders that are coming into the limit order book. Market orders are really a very, very short portion of it. So now, how do we want to measure the difference between offer and demand in order to measure the direction in which the market is going to move? So classically, what you're doing, you're trying to measure the volume which is available on the R side and the volume which is available on the bid side. So on the R side, this is orange V, right? Jim, why is spoofing illegal? Jim, this is by law. I think it doesn't have to be illegal, but I mean, by law, it is illegal, right? So, the classical way of doing.
So Samuel, by law, it's illegal, but you know, somebody has to have some justification for making this illegal. Your whole study shows that it's a very complicated calculation. It seems to me that this law is discriminatory. In other words, if you have a fancy algorithm to spoof, it's a sophisticated algorithm. You can't be guilty of anything. But if you have some stupid methodology that involves chat rooms, then you go to jail.
Yes, I mean, the people that have been convicted, they develop algorithm to spoof and they brag about it. They did not do it by just executing like that. I mean, they explicitly design algorithm in order to spoof the market.
Yeah, I mean, I'm just interested in your opinion. Why should it be illegal to spoof?
I don't think so. I mean, I don't want to justify that it is legal or not, that it should be legal or not legal. I mean, if you think, for instance, that you have a lot of potential spoofer everywhere, if everyone is informed, then you have a lot of spoofer playing against each other. And in the end, by equilibrium, this kind of behavior gonna fade away, right?
That's right. And then you would have a no spoofing principle, which would lead to more complex and interesting behavior of the order book.
Yeah, that's for sure. That's for sure. But so far, so I mean, this paper is just about, I look at one spoofer. I assume that there is only one.
No, I understand. We don't make the law. I understand.
Yeah, I mean, I'm not lawyer from this viewpoint. Really, absolutely not. So if I go forward, I mean, the imbalance that is classically looked at is to make the ratio between the volume which is available on the bid and the volume which is available on the ask, the difference, and normalized. So here I take just like the volume on the bid divided by the volume on the bid plus the volume on the ask. So if it is close to zero, right? I mean, you have less volume on the bid, and then the price is going to go down. And if the volume, I mean, if the imbalance is close to one, and this is the contrary, it means that you have a lot of volume on the bid side, and the price is going to go up. Yes, because you have a large demand. Okay. However, we saw that looking just at the touch of the limit order book and also what other people were saying, and we'll see that afterwards because the probability of getting executed is too large. Then you have to look a little bit deeper in the limit order book. So that's why we introduce this kind of imbalance that is a weighted average of what is available on the bid and what is available on the ask, right? And we take the same kind of ratio, but looking a little bit deeper, okay? So now, this is what I was saying before. If the imbalance is relatively close to zero, the price deviation is going to be skewed to the left, okay? So tendentially, the price, I mean, the price is going to go downwards, okay? And if the imbalance is close to one, the price tendentially will goes up. So dp minus, dp plus, okay? So in order to measure this kind of imbalance, so what we do is that the impact on the distribution of the price movement, so we make a very, very simple assumption over there, is that we say that we are a convex combination, the function of the imbalance between the price is going to go up and the price is going to go down. So this is the imbalance multiplied by dp plus, which should be the price deviation when the imbalance is very large, plus 1 minus the imbalance times the distribution, the imbalance, I mean the distribution when the imbalance is very low. So the price deviation is skewed to the left. Yeah. And throughout, we assume that dp plus is the flip dp minus, so they are symmetric. So coming back to our idea was buying 8 shares. So we have strategy 1, market order, buy now, delayed market order, buy later, or spoof and buy later. So I will go relatively quickly, first of all, because I am a bit behind schedule right now. But this is more or less what I presented before. I will just present the equation exactly, right? So strategy 1 is immediate market order. You get PH plus GH, so you pay just the price plus liquidity. You can delay the market order. So depending on the price deviation, which depends on X plus Y, then you integrate everything and you get an equation which is equal to this, which is equal to this one, the same one as before, plus some thing which depends on the initial imbalance, which is I bar, right, that you have here, okay? Or otherwise, you can have spoofing with a limit order. So if you spoof with a limit order, you will modify the imbalance right here from by adding this number WKV on the top. So it's going to be slower. It's going to be lower than the initial imbalance. And so if you have a price deviation and the price and V is executed, if you have a market order that's going to cross the price level K, then you get this payoff for the cost function that you have hit. So this is what you have to buy here. And here you get the price for what you sell, eventually if the price is higher than K. So altogether you get a price for the cost of executing this, of spoofing at level V, which is equal to PH, plus 1 minus QK. So QK is the probability that the price, the survival probability of the price deviation for the market order higher than K, right? 1 minus QKGH, so this is an optimal situation. You have the spoofing impact, which is H mu plus 2I of V minus 1. So if this person, if you can manage to bring I of V below 1/2, right, by pushing the law of offer and demand below the 1/2, then it's going to be negative here. But you have to pay, so this is the cost of being caught wrong way, where you have to pay QKG of H plus V plus V nu K, and nu K is this value here, okay? So this is a balance between both. Now, when you compare these three kind of costs, you can say, we give a definition in this kind of situation. The market admits a spoofing manipulation if you can find a volume for some price level, also some depth in the limit order book, such that the cost of spoofing is going to be lower than the cost of either sending an immediate market order or a delayed market order. And our first result is the following one. In a block-shaped setting, so it means that you have the same level of orders on the bid side, which is A, and B on the other side. So you get that if the initial imbalance is smaller than 1/2, you don't have spoofing manipulation if and only if you have this relation over there. So rho is the relative ratio of how much you buy. Okay, so this is how much you're going to buy. Mu plus is going to be the deviation in case the imbalance is very large, right? WK, this is the weight at which the impact of your imbalance on the price deviation. And nu K, this is also the probability, QK and nu K are related to the probability of being executed. So you have a if and only if condition if I bar is smaller than 1/2, and if the initial imbalance is greater than 1/2, it's only a if, right? So, but just to give a short idea about what's going on, if QK is small and byproduct nu K, spoofing is more likely to happen. So if the probability of getting executed is small, if I bar is close to 1/2, so you have more probability of having spoofing if the initial imbalance is close to 1/2. If the sensitivity of the limit order book to the imbalance is very large, then it is more likely to have spoofing. If the sensitivity of one level with respect to the imbalance is very large, it's going to be large also. And also what is quite interesting is that if you want to buy a lot with respect to the limit order book, you are more likely to spoof. It's better for you to spoof, okay? So here you have a small picture about what's going on. So the spoofing region as a function of the initial imbalance, right? So here this is a classical one with a set of parameters, but if you increase the probability of getting executed, so the spoofing region is gonna decrease. If you increase the sensitivity of the limit order book, the spoofing region will increase. If you increase the amount of shares that you want to buy with respect to the limit order book, spoofing region gonna increase. Same thing for the sensitivity with respect to the place where you are spoofing. And when you spoof deeper in the limit order book for equal weights, right, you're gonna have more impact on the way you're gonna spoof. So it's more likely that you're gonna spoof a little bit deeper in the limit order book. Now, the second question is, what is optimal spoofing behavior? So you can solve it semi-implicitly, right? So this is kind of a cubic root function. But what you can say is that when you have spoofing, yes, you get a new imbalance after the spoofing, and this is what we are interested in too. So if the spoofing, when you look at the spoofing after the guy spoofed, when you look at the imbalance, it's going to be decreasing, and by how much you can solve this like this. And
Samuel, we have about 5 minutes left or so.
Okay, so it is decreasing as a function of the relative impact, okay, W and mu plus, and this is increasing as a function of getting executed, okay. So here you can see, depending on the level at which you are spoofing, if you spoof close to the touch of the limit order book, it will have almost no impact, right? While if you go a little bit deeper, you will tend to distort the imbalance. Okay, so this is mainly the basic facts that you can say in terms of limit order book. I will, since we don't have much time, I won't speak about the round trip situation, but you have a similar situation also where instead of trying to buy an order, you spoof and you drive the market down and then you buy something. Let me speak that. And let me go directly to the calibration story. So the first thing is that we have a market situation and we want to calibrate this model. So we don't have so many things, but we have to calibrate in particular the imbalance in terms of the weights, okay? So it was a quite difficult story because you have to build up full limit order book out of the data that TMX provided us, and these are extremely large data, and you have to build full limit order book everywhere. So the first thing that you have to do, you have to calibrate the frequency at which you're gonna sample and observe this imbalance. So you choose a sampling frequency on which you're gonna observe this. So for the couple of market that we have, depending on the kind of equity you're looking at, you will have different kind of sampling frequency going from 2 seconds to 200 seconds. So like 3 minutes about, right? And having this at hand, then you can start to calibrate the imbalance. And this is where it starts to be interesting. When you go deeper into the limit order book and you change the different weight, the imbalance over the market is going to change quite a lot, right? So you want to calibrate this imbalance in order to match better the next price behavior according to the information of the imbalance. And this is what you are going to do using maximum likelihood, but this is kind of calibrating a stochastic kernel, if you see what I mean. So you have to do this through several steps. But doing so, we could calibrate it through several markets. And as you can see, here you have like 10 different stocks, right? And the relative weight, which has an impact on the future price movement, is rarely the one which is happening on the top. It's more, you have more impact when you go deeper in the limit order book and through across different kind of stocks, right? We can calibrate also the price deviation as well as the execution price, right? But let me spend the last 5 minutes about spoofing detection, because this is what we intended to do at the beginning. If you monitor the imbalance from the very beginning, you won't be able to see anything, right? Even if you calibrate the imbalance, because it's just like noise. So one of the first idea would be, okay, when you have, so in our context, a spoofing behavior is successful when you have a market order. So we will look at the market order and we want to look at the imbalance before this market order and right after this market order. So if you have a legitimate market order, you will observe the imbalance before and after, and you suppose that it's going to be a kind of equilibrium, like across many times, it should always behave the same way. If you have a spoof market order, however, the spoofer observe I minus, it will spoof and decrease the available imbalance, yeah? And then after the market order is sent, the market comes back to equilibrium and it's gonna be I plus, okay? So you will see two different kind of behavior if you have a legitimate market order or spoof market order, according to what we said before, okay? Now, the first thing that you can do is that you look at a short time horizon and you look at all the different imbalance that you have before each market order and market orders, and you compare to the long-term kind of market order that you have before. It's gonna fail because this kind of, observing this market order is highly non-independent, okay? You have a lot of autocorrelation because this information depends very much on the state of the market right before, right? It could be like bearish market, bullish market. So you won't be able to make some nice test about it. And it doesn't give you any information about the spoofing at all. Now, the only thing that you have between both is a statistical link to discriminate between I minus and I spoof minus is what you observe after the market order. And here you have a scatter plot about what you have before and after, the imbalance before and after, and you get a kind of standard behavior. If you apply the spoofing on this market, you will have a shift of the joint distribution to the top left, okay? So you want to be able to detect this kind of story, right? So when you look at this joint distribution, you say, okay, well, let me check, actually monitor the short imbalance and see as a jointly and see if I am in the situation on the right panel, on the left panel. But once again, you will face also the same story that the market is highly non-independent, okay? So the only way that we thought that is able to do that is really to monitor the imbalance before given what you have after, okay? So condition on the imbalance right after the market order on short time horizon, I will measure the distance between the short time imbalance and the natural imbalance that you should have before a market order. And I will do exactly the same condition on the imbalance after. I will measure the distance between the short time imbalance and the spoofed one, okay? And if I am close to the standard imbalance, no problem. If I am close to the spoofed imbalance, problem, okay? So you have to take care a little bit about this one, but I have like, let's say 1 minute to present a couple of, so first of all, it's a little bit more independent in that case, if you condition on what happens after, but you can measure here. So the red line is actually the distance between the short-term imbalance, what you observe, and the spoofed imbalance, the theoretical one. And the blue one is the distance between the short-term imbalance and the standard imbalance, okay, that you should observe before the market order. So actually they should be very far apart. So the blue line should be close to 0 and the red line should be high. But when they cross, or when the red line goes down and the blue line goes up, it means that it is more likely that you have spoofing happening at some point. So this is what is going on for these guys. So here you have BEHAMOR and CNR, which are relatively large stocks, right? And this is from June 5 to June 9th. Here on this panel, you have here CPG and PPL, which are relatively smaller stocks. And for instance, in the case of PPL, it doesn't cross that often, but here during, I mean, here this is almost during 2 hours, right? You have a lot of time where the imbalance that you observe in a short time horizon is definitely closer from the spoof one than from the standard one that you should have in a non-spoof situation, so to say, okay? So I think I'm done. So here is the conclusion. this is a very simple approach to spoofing. We would like just to try to understand what's going on with this story and how the offer and demand is impacting the market. So you have some calibration, some kind of attempt to quantify using Wasserstein distance, but also by looking a little bit more clearly about what is happening on the market. If you do this too direct, it won't work because you don't have independence. But you still have many questions left for further studies. First of all, shall spoofing be prohibited? It's a question because, I mean, from a law viewpoint, this is absolutely not clear how to prosecute something. Refine calibration, refine the quantification, find also alternative approach. I'm pretty sure that this is, I mean, one way of looking at that kind of problem is not enough. One should have a battery of kind of quantification if one wants to detect spoofing somehow. The robustness of the calibration over time. So we are running this right now. So we'll have more results in the next 2 weeks about it. And also, well, is it indeed somehow detecting spoofing? This is the main question. I mean, we are measuring stuff. We don't know exactly if it is spoofing because spoofing, I mean, the definition is not clear, right? However, we wanted to give potential way for regulator, just like a red alarm, to look at a place and just dig a little bit closer instead of just tapping the phone or going to the golf club and listening to what traders are saying, right? So this is, I'm sorry, it was a little bit too long. I was a little bit too long about it. So thank you very much. And the paper is on archive right now. But we're gonna update it because a lot of calibration is running right now on the cluster of TNX. So we will update with additional statistics and measures and calibration procedures over there. So thank you very much.
Thank you, Samuel, for a wonderful talk. I know we have to end by top of the hour, so we had a couple of questions. Let me just read them out to maybe to save a bit of time. They're both about market design. So one question says, could this model inform changes to the design of the market to make spoofing difficult or more costly? And then there was in the Q&A, there was a similar question from Mohammed Ram saying, it seems that adding a minimum resting time for limit orders would not favor spoofing. How would minimum resting time affect your model?
First of all, the model is very simple and make a lot of assumptions how the market is set up. I mean, it's just like one spoofer and a lot of stupid noise trader over there, or a lot of stupid algo trading behind it. Will it, I mean, if it is implemented, will it change the way people are acting on the market? If you prosecute people because you get a red line, then actually everyone will tweak his own algorithm in order to be below the threshold. That's for sure. I mean, the goal is not really to provide the ultimate way to detect something on the market. First of all, because it's too simple and it's not clear. The goal was really to try to, okay, you have this question with spoofing. Is there a way to detect something which is kind of implicit behind the market? I mean, normally you don't see it. I spoof of I minus. I don't see I minus. I see eventually I spoof of I minus. So it's a bit difficult. So I'm not sure. Okay, if it is implemented, yes, naturally it will change the way the market behave, but I mean, it should not be implemented that way. One needs a little bit more about it. That's for sure. Now, there was
okay, sorry, I think we're out of time, so let me stop. So again, as a reminder, we will continue with the discussion afterwards. So if you have more questions, I know there's more questions in the chat, we can continue after 11. I just want to see the the mic for a couple of minutes to Agostino, who has some announcements to make from the activity group itself.
Thank you.
So thank you again, Samuel.
Thank you, Mike, for hosting, and thanks, Samuel, for the great talk. So I want to make some announcement regarding, first about the next meeting. It will be essentially a panel discussion. It will be on October 15, and it will be mostly about like the consequences and the implications of COVID-19 for financial markets. So it's really a little bit atypical with respect to the meetings that we have had up to now, but we have secured 3 great panelists working at the Bank of International Settlements, New York Fed, and another one that has plenty of experience in the mortgage market, and they will describe exactly what is going on in terms of like treasury liquidity, in terms of margin breaches in major clearing houses, and also what is happening to the housing market due to the regulations about forbearance of mortgages and delaying payments for homeowners. So it should be quite an interesting panel, especially because these people are like well familiar and well-recognized experts in these topics. And then I want to make some announcement about the conference. So we are moving forward with the organization with Igor, and we are looking forward to an in-person and a very exciting meeting. But of course, as you know, the success of the conference depends entirely on the community. So it's not only up to the organizers. And for this, I want to remind a few deadlines that are coming. So there is the deadline for submissions of mini symposium proposals that will be on December 3. So please submit proposals, and also encourage your friends, colleagues, and students to submit. Also, there is a deadline for the contributed talks, lectures, and posters. So the deadline here is this January 7, 2021. Feel free to nominate, and sorry, do nominate people for the Early Career Prize and for the Conference Paper Prize. So the deadline for the Early Career Prize is on October 15, and the deadline for the Conference Paper Prize is on February 15, 2021. And finally, for students, there is a SIAM Student Travel Award, and Early Career Travel Award applications are currently being accepted, and the deadline is December 17, 2020. We will be sending an email to recap all these deadlines. They are also on the website of the conference, but I think it's handy to have them in front of you. So you will get an email through the distribution list reminding you of all these deadlines. And that's all what I wanted to say. Thank you everybody for attending and for joining and for asking very interesting questions. And we look forward to the informal chat now.
Thank you. So I believe we're going to stop recording and we're going to move to the informal discussion.